All right, so I'll start by just drawing a table.
Okay. So in this table, we have 3 stars. Stars A, B, and C. They all have an absorption line at 480 nanometers.
Okay.
So first, star A, we are in front of it, and it's really close. So since it's in front of us, it's going to be blue shifted, right?
Yeah, so then this number will just get smaller since it's shifted to
Yeah.
shorter wavelengths.
And since it's close, like the closest thing in front of us, it wouldn't be that big of a shift, right?
So yeah, so why don't we just say it's shifted to 470 nanometers?
Yeah, that works.
All right.
So star B next is, it's far away from us, but behind us. So since it's behind us, we're moving away from it. So it's going to be red shifted.
Yeah, so then that means that this number is getting bigger because it's
Yeah.
shifted to longer wavelengths.
Yeah.
And then you said that it was pretty far away from us, right?
Yeah, it was far away, yeah.
So then it'll be a bigger shift than that. So why don't we just say the line was shifted to 520 nanometers?
Yeah, I'm cool with that.
All right.
And lastly, star C, it is the farthest thing away from us and is in front of us.
So then that means it's going to be blue shifted like A.
Yeah.
But since you said it's really far away, it's the
Yeah.
farthest thing, then it should be the biggest shift. So
Yeah.
why don't we just say it's shifted to 400 nanometers, since that's a big shift and it's also blue shifted?
Yeah, I would go with this. Do you want to get an instructor to check this?
Yeah.
Okay.
Alright guys, let's look at stars A and C first. Are they red shifted or blue shifted?
Blue shifted.
So why did you pick 470 nanometers for A and 400 nanometers for C?
Well, we know that the light for star A and C are blue shifted. So then that means that the 480 nanometer line will be shifted to shorter wavelengths. So these are both numbers just smaller than 480.
And since C is farther away from us than A, it's going to be shifted to a lot shorter wavelengths because it's farther away.
So you guys are right that the numbers will get smaller since the light is blue shifted. But you should remember that the distance between the objects does not actually affect the amount of Doppler shift. It's just the motion.
Okay, how does that help us though?
Well, you're moving towards star A and C at the same or different speeds.
It'd have to be the same
Yeah, it'd
speed,
have to
right?
be, yeah.
Yeah, the same speed.
So if you're moving towards stars A and C at the same speed, will the amount of Doppler shift be the same or different for stars A and C?
Oh, then would it have to be the same for A and C?
Oh yeah, 'cause since they're both being blue shifted, they would both shift to the same amount.
Yeah, since
So-
we're going at the same speed towards them.
Yeah, so we'll just change this one to 470?
Yeah, because
Okay.
then that means that's the same amount of shift. Perfect.
Let's look at B. Is B going to be red shifted or blue shifted?
B is being redshifted.
And by how many nanometers did you determine the 480 nanometer line would be shifted for star B?
40, the difference between 520 and 480.
And what about stars A and C?
It's just a shift of 10 for both stars A and C.
And are you moving at the same speed away from star B that you're moving towards stars A and C?
You'd have to be.
Oh,
right?
yeah, we have to be. So does that mean the amount of shift, the amount of blue shift for A and C has to equal the amount of red shift for B?
Oh, yeah, that would make sense. So it'd still be getting redshifted as it's moving to longer wavelengths.
But just by the same amount as A and C,
Yeah.
so it'd only be 490.
490, okay.
So how does that look?
Great job. Those are now possible values for the shifted 480 nanometer line.